So I spent the past hour recording and realized I'm a heavy mouth breather and you can hear everything. And the video is kind of confusing. I spent a lot of time thinking and messing up. So now I kind of know what we want to do for the problems today. And instead of spending that time trying to figure it out, we're just going to go straight into the solution and I will explain my thought process through it. So earlier I did, about an hour ago, I did the two-sum and the group anagrams. Group anagrams is the first medium problem I've ever done, and I had to look into the solutions tab in order to figure it out. And after figuring it out, I mean, the solution wasn't the worst thing in the world, but it's not something you would normally think of intuitively without probably previous problems you've seen. So I think we're going to save group anagrams for the video tomorrow, so I can spend the entire video working on one problem. And in the group anagrams problem, which is this one, we looked at, what's his name, Ashok Varma's solution, and he said at the bottom, if you're a beginner, try to solve these problems. So the two-sum is the other problem, and then the palindrome number, and remove duplicates from the sorted array. So the palindrome number is, if it's one way, you reverse it and do it the other way. So it gives you a number, and then you give you the palindrome. I think we might do the palindrome and the two-sum again. So we can go ahead and go to problem list and go to two-sum. And here's my solution, so we'll go ahead and delete this and redo this one. So my original solution is the n-squared solution, and if you can see in my submissions, an hour ago I submitted a 35 millisecond solution in Java, and that was the n-squared solution that I came up with. And that solution is fairly intuitive. I feel like most people will look at this problem and solve it will come up with the solution I did, and that would be to check one number with the rest of the numbers, and if their sum is equal to the target, then you would return the indices, or set the array to the indices. The other solution was, or the quick solution would to be to check the complement, and I think we're just going to go with my intuitive solution first, and then we can check out the submissions tab and look at the other solution. So the original solution is you need an int array of indices. I'll set that equal to a new int array of size 2. And this will hold the two indices that we return, right? And then we need to check the nums. And we want to do a normal for loop, because we need the indices themselves. So less than nums.length, then I plus, and then we need to check int j is equal to I plus 1, because we want to check the next value. So like, for example 1, this is 2, and then I plus 1 would give us 7. And then we will check 7, 11, and 15 compared to 2. And then if that doesn't give us a solution, we'll check 7 against 11 and 15. And then finally 11 versus 15. And then once we get to 15, it won't run the second loop, because there's not a number past 15. So we'll get the plus length and then j plus plus. Go ahead and format all this correctly. And then inside this loop, we want to check if the nums at I plus the nums at j is equal to the target. And if that's the case, we want to set the indices of I equal to target. And then we'll check the indices at j equal to the target. And then we can go ahead and break out of the first loop. And then if we just check the indices at 0. If that's not equal to 0, we will also want to break out of this loop. And then we want to return the indices. And that should give us a correct solution. We can do a little bit of data validation. So if nums is equal to null, we just want to return null. And then if nums is less, num.length is less than 2, or return null again. Because you can't have two integers equal the target if it's less than 2, and then if there is not an int array and it's equal to null, we can go ahead and return null. And then so we can go ahead and, pretty sure there's no of course that wouldn't work. Let's go ahead and run it so we make sure there's no compiler errors. Indices I, okay, and we're checking the quality of that. Of course that wouldn't work either. Next to is out of bounds. I don't know what I was thinking here. So we want to check index 1 and 2, index 0 and 2, and then we want to set that equal to I and j. Getting a little bit ahead of myself. I said I already knew these solutions, but here I go messing stuff up. Runtime 0 milliseconds, 3 milliseconds. Okay, and we can go ahead and submit this now. Yeah, there we go. We got a 34 millisecond runtime. We'll go ahead and check our submissions. It's 1 millisecond less than that one, and then most of my previous on May 9th were like around 39 and 44. And then we can take a look at the solutions I took from the solutions tab. And this one checks the complement of each. So you create a map of integers and integers, and then num to indices is a new hash map. Then we get num length is equal to nums.length. And then the num length, we loop for every integer in the nums. Okay, and then we take the int, we take the complement of the target minus the nums. So the current number we're looking at, the complement would be the other number we're looking for, right, to equal the target. So we can check if num to indices contains the key of the complement. So we'll check for the complement, so the other number we're looking for, right? And it's not the current complement's index, right? So we'll check if that does not equal I, because we don't want, because like if the, in the first, where's it at? In example 3, it's 3 and 3, but we don't want to like give back 2 zeros. We want to give 0 and 1. So we'd have to find the other array index that is equal to 3, right? So we want to make sure the complement does not equal the current index. And then we want to return a new int. Yeah, so this returns a new a new int array of I, the current index, and then the other index of the complement. And that should be able to, and then if we don't find the complement, we want to go ahead and put the current number into the array with the index value. And then if we get out and we don't find a complement, then we return a new empty integer array. Yeah, that one wasn't too bad. So this one I haven't completed before. As you can see in the submissions tab, there's nothing. I didn't take a look at these solutions. Well, how do we get rid of that? Okay. Maximize, no. We want to get rid of that. Okay, put it back in here. So I came from Ashok Varma's solution from the group anagrams. So it automatically opened his solutions tab. But we haven't taken a look at that yet, so I'm going to try to come up with my solution for this. Given an integer array of nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same, then return the number of unique elements in nums. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums containing the unique elements in the order they were present in nums initially. The remaining elements of num are not imported, as well as the size of nums. Return k. Custom judge. The judge will test your solution in the following array. So that's the input array. That's the returned array when we change it around. Then it takes the index of unique values. Okay, so we'll take a look at the examples. So we get 1, 1, and 2, and it wants us to return 2 because there's only 2 unique values, and then I guess store 1 in the final index. Your function should return k equals 2 with the first 2 elements of the nums being 1 and 2 respectively. It does not matter what you leave beyond the return k, hence they are underscores. Okay, here's a bigger problem. So there's 0s, 1s, 2s, 3s, and 4s. And then the first 5 digits is only 0 through 4. So it wants us to reorder the array. Okay. That's not too bad. Let me try to think of a solution real quick. I mean, we could store every element into a set, okay? And then the set would only have the elements we want. And if we do a linked set, our insertion order should be kept. Instead of a hash set, they usually go wherever. And then from there, we could just set the first value, the length of the set is equal to k. And then we could loop through k and just set the values to each point of the set. That'd probably be the easiest solution, probably not the most efficient or okay. I think we're gonna solve it that way, and then we'll take a look at the solutions tab and see what the most efficient solutions would be. And I think this is a fairly good concept to have, not concept, a good way to approach these problems is try to come up with your own solution first. It's your critical thinking skills, of course. Your own solution might be slow, it might suck, but you're still thinking about the problem and coming up with a solution, right? So you're still solving the problem technically, not in the quickest way. And then you can go ahead and check out the submissions tab and see what the quickest and most efficient solutions would be. So you can kind of compare and contrast against your own, like what you did well, what you did wrong. And then from there, on future problems, you were able to think back to the correct solutions and kind of utilize some of the approaches they took, right? So I think we're going to get a new set of integers. We'll call it just num set. We want to have a linked set. Excuse me. And then for int I, or we can just do int num, int nums. We want to do numset dot add num. And then from there we can set int k is equal to numset dot length. I think it's not length, it might be dot size. We can just run the see what the compiler says. Let's go ahead and take a look at the links, the set interface. Unknown, implementing abstract, concurrent hash map, concurrent skip list set, copyright enum set, linked hash set. Okay. That would be the problem. So it's called linked hash set, not linked set. I'm not for sure why set integer num set and linked hash set of integer. I just sometimes I think I shouldn't be a programmer. I think that's very apparent sometimes, but that should work now. Might be dot size. Yeah, size. Okay. So that should give us the K, and then we can do for int I is equal to. Yeah, we want to do int I is equal to 0. I is less than. Well, it might be beneficial to int I is equal to 0. And then we just go ahead and do int nums in the num set. And we want to do I++ to get the index value, right? And then we can say nums of I is equal to num. And then we want to return k. Yeah. Go ahead and submit this and see if we get, yeah. So we got 3 milliseconds runtime. Solutions use 0 and 1 millisecond. So we're gonna do a little code review so we know, kind of see what's going on. So I created a set of integers, right? And then we went ahead and looped through the entire nums array and added each number inside into our set. Okay, what that did would give us basically a list of the unique values and only the unique values with no duplicates, which is kind of what we want for the first few. So then we can set k equal to num size, and then that gives us the k they want us to return. And then we go ahead and give I equal to 0 so we can loop through the num array and access the first k, like 0 through k indices, right? And then since num set is the size of k, it'll go ahead and it'll run this loop for the amount of k. So we don't have to do a for each loop or a for loop. This makes it just a little bit more concise to show that we are getting each number inside of the num set, right? And then we would go ahead and access the index value of the first loop would be 0, and then set that to the first unique value we had inside of our array. And the reason we can do it this way is because it gives us the array in non-decreasing order already, and then it wants us to add the values in non-decreasing order. So the order, and the reason we use a linked hash set is because the order is preserved no matter what. I don't think the solution was that bad. We can go ahead and check out the solutions tab and see. So we can use Nits because he has, this is pretty cool. He has videos behind most of the problems, kind of like what we're doing, but ours is not more about going over the solution, more about coming up with the solution and my thought process behind it. Use 2 pointers, 1 pointer with the current number, another pointer to be placed where the replacement should be. All duplicate numbers and shift each unique number to the left of the array. The first element is always unique since the array is sorted. The first element, num0, is always unique, therefore there's no need to compare first iteration. Go ahead and check the solution. So int I equals 1 and j equals j. J less than num length, j plus plus. If nums j does not equal nums I minus 1. plus I is equal to minus J. So this one, in this solution, all they're doing is swapping the values. This one would have a smaller memory space complexity, say O of 1. In ours, we have to create a set that is equal to the length of nums. So ours would be a space complexity of O of n. And the time complexity is still O of n because we loop over each number, kind of like what they do. Because you don't know if the last element is unique until you get to the last element. And for ours, it's... would it be of O of n plus m, where m is the amount of unique elements? Not for sure. Yeah, but this solution is fairly easy. Thanks for a great explanation. Okay, but however, I'm copying unique elements. Yeah. So if you want to know how to solve a solution, I would suggest going to someone like, what's his name? Nits. Because mine is just kind of like my thought process and kind of have documentation about my progress through this. But I think that's the only two problems we're going to do today. We might do the palindrome number next time, and then, or we may do the group anagrams one again and kind of explain it a bit better, and instead of spending most of the time staring at the problem, I'll actually go straight into solving it. So maybe I'm not breathing as heavy in this episode. I know my mic picks up a lot. I'll have to try to figure out how to cancel out white noise, aka my breathing, and figure that out in the next episode. But I hope you have a blessed day. I hope you all enjoyed this episode. This is episode 2, and y'all be back for episode 3. I hope you have a great day. Once again, stay blessed, stay healthy, and I will see you on the next one.